reflection losses. So this reflection losses is related to the standing wave ratio. Okay, so just note down first, then we'll write the equation. If your line is not matched, if your line is not matched to its load, if your line is not matched to its load, the energy delivered by the line to the load is less than if the impedances are properly adjusted. I'll repeat once more this line. If your line is not matched to its load, the energy delivered by the line to the load is less than if the impedances are properly adjusted. This effect is considered as due to reflection. This effect is considered as due to reflection at the junction and makes its presence due to the reflection at the junction and makes its presence presence known by establishment of a refracted wave and a standing wave system. Establishment of a refracted wave and a standing wave system. Standing wave system. Next paragraph you note down. The voltage at the maximum voltage point, is due to the in phase. The voltage at the maximum voltage point is due to the in phase, INPHAS. In phase, sum of the incident and reflected waves so that what is the equation 3 we have written in power and impedance measurement? E maximum. We say E maximum is equal to E maximum IR ZR plus R0 by 2 1 plus modulus K, power measurement and impedance. So in order to see the same thing from which equation you are taking? Third equation of the power and impedance measurement. So note down E maximum is equal to incident wave, voltage at the incident. E represents the voltage, I represents the incident. I represents the current, incident and refracted wave, right? What will be the change? We'll see. The minimum voltage is due to the minimum voltage is due to the difference of the incident and refracted waves. The minimum voltage is due to the difference of the incident and refracted waves. Incident and refracted. Difference between the incident and refracted waves. So how will the equation change? Yesterday the power measurement E minimum. What will be the equation change from this equation? Minus. Minus. In the place of plus it will be minus. Here also minus. There also minus. That's all. So whenever you understand clearly with the power measurement, is that not equal to what? Or not? Is that not is equal to what? That is equal to the value we already seen. In the second unit onwards, either you can use Z naught or R naught. Right? The impedance is equal to the, since it is resistive, Z naught is equal to what? R naught. So either you can use Z naught or R naught. Both represents the characteristic impedance. Right? Yes or no? We already got the first beginning itself. So see, the change in the minimum is only just the value. So you write E minimum is equal to E modulus of EI minus modulus of ER equal to modulus of IR Z naught plus R naught by 2 1 minus modulus of K. See, if you understand and study these small changes only in the equations, right? Next we have to write in terms of this one, in terms of standing wave ratio. No doubt. Hence the standing wave ratio is, S is equal to what? E modulus of E max by E minimum. So that is equal to what? Modulus of EI plus ER by modulus of EI minus modulus of ER. So this is equation number 1. So just we have written what is the reason we are going for the refraction of the unmatched light. And then what is E maximum equal to? E minimum equal to what is the standing wave ratio? Okay, next you know now. Using equation 16. Using equation 16 of the power measurement. Using equation number 16, that you should put it in box where it comes. Okay, put it in box. That we need not write for the examination point of view, but you have to know now. Using equation 16, bracket power measurement and impedance. Using the above result is this result. Using the above result, using equation 16 and the above result in bracket we put equation 1. Use for the total power transmitted along the line. Use the total power transmitted along the line and delivered to the load. Use for the total power transmitted along the line and delivered to the load. So you see equation 16, what is the equation given? P is equal to E maximum into E minimum by that is what I have to write. P is equal to E maximum into E minimum by R. E maximum into E minimum by R naught. Now we have to use the above result in this equation. See, equation 16 of the power measurement is P is equal to E maximum into E minimum by R naught. What did I have said? You have to use the above result in that equation. What is E maximum here equal to? That is substitute that. P is equal to, substitute this equation. P is equal to modulus of EI plus ER into modulus of EI minus ER by, what is the value? R naught. Just we are substituting the E maximum and E minimum value. Okay, just substitute the E maximum and E minimum value. So now it is in multiplication. Yes or no? It is in multiplication, multiplied. P is equal to E modulus of EI square minus modulus of ER square by R. So this is equation number 2. Right? We are not creating any new equation under the refraction law. This is a 6-mark question. 6 or 7 mark. Remember, because every question I have asked for the unit 2, all the questions I have covered. So this is a split question. This question is also that. Every question is that derived. So this is 6 to 7 marks something I have given. Are you able to follow? here we are seeing in terms of standing wave ratio. Standing wave ratio. So this derivation, 6 or 7 mark question is very easy. E maximum, E minimum, standing wave S is equal to E maximum by E minimum. We are writing the power impedance E maximum in E minimum by R naught value. You are just substituting the value and getting and just plotting the graph standing wave ratio versus the power delivered. So this is reflection loss in terms of standing wave ratio. Then 2 lines you have to write the theory and write one more equation. That's all. So the stop saying if you are just listening to the class and then you are writing note means you are learning. Just it needs 5 minutes alone to learn this topic. So you can cover all the topics in the internal test if you have learned already, if you are just concentrating. So you have to concentrate in the class. See, if your mind is not here, you cannot remember any point. But if you are fully concentrated, you can remember the points when you write one time the equations and all and practice. Right? That's what we are teaching you. Otherwise, you can sit in the class, home and study. Right? Yes or no? Okay, note down this point. First you can note down this point and if you want you can draw it. Note down. This expression is recognized. Which expression? The equation number 2. Okay. This expression is recognized. This expression, bracket you can put equation number 2. This expression, bracket, equation number 2 is recognized as the difference of the two power flows. This expression is recognized as the difference of the two power flows, one being the power, one being the power Pi transmitted in the incident wave, one being the power transmitted Pi in the incident wave, the other being the power P of. This expression is recognized as the difference of two power flows, one being the power Pi transmitted in the incident wave, the other being the power PR traveling back in the reflected wave. Traveling back in the reflected wave. Other being the power PR traveling back in the reflected wave. Note out the ratio of power. The ratio of the power P delivered to the load, the ratio of the power P delivered to the load to the power transmitted by the incident wave, the ratio of the power P delivered to the load to the power transmitted by the to the power transmitted by the incident wave is P by Pi is equal to, what is P by Pi? P by Pi. P is what? Power is what? Incident wave minus refracted wave. So Pi minus PR, incident wave is Pi. So what is Pi minus PR equal to? P. P. The value is what? We have already derived in equation number 2. What do you have derived? This is equal to modulus of EI square minus modulus of Eon square by, here instead of that only we have to write power P alone, right? Pi divided by the Pi is incident wave voltage square. See, this what Pi is what? EI square. PR is what? VR square. So what is Pi? EI square. So that is equal to what? EI square by EI square will be, so you can write it as 1 minus modulus of Eon square by modulus of EI square. So that is equal to 1 by standing wave ratio. So this we can write again, rewrite. This is P by Pi. So I can rewrite this P by Pi again as 1 minus of S minus 1 by S plus 1. Standing wave ratio 5. So that can be written as S plus 1. So very simple derivation.